Welcome to Embedded FM. I'm Alicia White alongside Christopher White. This week we're going to talk about FIRST Robotics, a program that encourages robots, which we are in favor of course. Joining us is Michael Hill, a former participant and current mentor of FIRST Robotics. Before we begin, I understand that some of you may listen to that other podcast, The AMP Hour. Maybe you've already heard their call-in show, sort of a car talk for electronics. There's going to be another one, and we've been invited to answer questions with Chris Gamble, January 6th, 2016. If you have a question, please email feedback@theamphour.com or hit our contact link. Include your name, location, Skype name, and what you want to talk about. We look forward to hearing from you. Remember, January 6th. The rest is in the show notes. So now, on to robots.
Hi, Michael. It's good to talk to you today.
Hi, it's good to talk to you.
Could you tell us about yourself?
Yeah, sure. So when I was in high school, I was told to join a FIRST Robotics team by my friends, and I had no idea what I was getting into. But it turns out it has guided me throughout the rest of my life so far. I've become I was a student on the teams, and I've been mentors on the teams, and really we're just about gaining more interest in STEM education.
Well, I have no problem with that, of course. So now we're going to go to lightning round as a more thorough introduction. The goal here is one-word answers with no explanation, except, of course, then I'll ask you for explanation, but that's okay. For most of these, just answer as fast as you can.
Sure.
Favorite fictional robot?
R2-D2.
Favorite programming language?
Python.
Programming language high schoolers should learn first?
Python.
Should CS or programming be a required course? In high school?
I don't think so.
Object-oriented or procedural?
Object-oriented.
Hardware or software?
Software, but I like hardware more.
Most important to your day, soldering iron, keyboard, or mouse?
Keyboard.
Mentor or coach?
Mentor.
Gryffindor or Ravenclaw?
Gryffindor.
Science or technology?
Science.
I don't understand this one here. Walking or stereo camera?
And a robot.
Oh, okay.
Which is more important? Which would be a better robot, one that had walking or a stereo camera?
That one, okay.
Stereo vision, easily. Walking ones fall over.
Are self-driving cars or vacuuming robots with artificial intelligence more likely to start us on the path to world destruction?
Self-driving cars.
Robots or not? BattleBots.
They're robots.
No.
They are robots. I don't care if you want to admit it, but they are robots.
Have you seen the new Star Wars movie?
Of course.
Leia or Rey?
Leia. Sorry, there's just not enough information about Rey. I don't want to, I don't want to be standing on firm ground on one way or not, because we just don't know enough about her yet.
Fair enough. What programming language should robots have to learn in order to best take over the world?
C++.
Python for everyone else, but C++ for the robots.
Well, they're the ones that can actually figure it out.
What would you prefer to drink at 4 p.m.? Coffee, Mountain Dew, or champagne?
Beer.
Fair enough, yeah. Maybe should be added to the list. Where do you expect extraterrestrial life to be found? Mars or Europa? Or somewhere else?
Probably not in our solar system. I would say somewhere else.
All right. So first, this is about robots fighting, right? Flamethrowers, ice picks, that sort of thing?
Not really. There's a little bit of that, but not really.
Okay, so first is a high school, mostly robotics competition, right?
Correct. It stretches all the way down to the elementary schools as well. First FRC, the first robotics competition, is all high school.
And there's a first technical challenge. What's that?
That stretches down to the middle school, and it also encompasses the high school as well. It's a little bit smaller scale, so it's a lot cheaper to compete in, but it's just as much competitive.
And then there's first Lego League?
Yeah, first Lego League. Yeah, that was a partnership that first had developed with Lego some time ago, where I'm not even sure if it's older than FRC. I don't think it is, but they were. You need to program a Lego robot to complete tasks just like we do in FRC, and this is all done in like elementary and middle school. I had the opportunity to do it in middle school, but I just didn't really know about it too much, so that's why I didn't do it.
Is that using the Mindstorms set, basically?
I think so. Yeah, I don't know too much about it. I've only volunteered at one event, and I didn't get down to much of the technical stuff, but I think it is the Mindstorms. I think they used to use the old yellow brick RCX things, but then they've gotten to the higher grade stuff.
But FRC, that's the one you know the most about.
Yeah, it is. Yeah.
Okay, so as someone who is an engineer who has never heard of FIRST at all, how would you explain what it is you do?
Oh, I would say it's all about approaching a technical challenge with high school students and seeing the program from beginning to end. It involves a lot of programming, electronics, design, and manufacture, and it's all done in a super compressed schedule. So any kind of schedule that you see at work, compress that down, a lot, and that's the kind of pressure that we're dealing with. So it's high pressure, highly technical stuff that we're doing.
Oh, so it starts January 9th, which is coming up real soon.
Yep.
And that's when they get their challenge. Until then, nobody knows what the goal of the game is going to be, because there's like games, right?
Yeah, yeah.
You explain this.
Yeah, so I guess the big difference between like a BattleBots thing and FRC is that we're actually a task-oriented competition. So there's actual tasks that we have to complete, whether it's shooting frisbees in a goal, making baskets in a basketball hoop, or stacking up totes. Those are actual things that we have to accomplish. It's not just beating up your opponent. So yeah, the 2016 game, they've released it. It's called Stronghold, and we really don't know too much about it.
That's all they've released, right? Is the name?
So they've released a trailer, something that they've never done before. So we know that it's kind of got like a medieval theme, but other than that, we don't really know too much about it, except that they were working with Disney Imagineers, and that's really about it. There's a couple other little subtle hints that we've picked up from some of the vendors and the director of FRC. He's kind of let a little hint out, but we haven't really gotten anything that we can sink our teeth into yet that tells us about the game yet.
If it were me, that would make me anxious.
Oh yeah,
that sounds like something very complicated coming up.
Portcullises.
Yeah. So knowing that they were working with Disney Imagineers to develop the game, there's a few things we can kind of guess at. There's some mantras that Imagineers use when they design the theme parks at Disney. And so everything has to do with either telling a story or having like some kind of strong concept. And in this case, in the teaser, they've told us that it's going to be a medieval kind of theme. So they also pay attention to detail. And so everything should fit the theme or concept or story or whatever. and there has to be continuity throughout everything. And there's also always one main attraction. So if you've been to Disneyland or Disney World, there's like Cinderella's castle, right? And at Epcot, they have the large ball, and in Animal Kingdom, they have the Tree of Life. So my guess is that there's going to be some one large element in the middle of the field, but my guess is as good as anyone else's.
So does it tend to be individual kind of trials where you put a robot in per team and they do something, or are there robot versus robot, or not cooperative but sort of competitive things?
So we always work as alliances. At least we have since about 2004-ish. There's always been an alliance. No, it's even gone farther back than that. I don't even remember when. I think 2000 or 1999 was the first year with alliances. So when we do an alliance, it's multiple teams are on the same side trying to complete the same task. However, generally there's two alliances that are competing with each other at the same time.
Let's talk about 2015 in particular,
Sure.
because this is all theoretical. It was the 24th year of competition. There were nearly 3,000 teams with 70,000 plus students and nearly 20,000 mentors. 19 countries, looks like. What was the goal? What was the task?
So the 2015 game was quite different from any other game that we've ever had. For the first time, there was like no hitting each other or defense. So two alliances were playing at the same time, but there were no direct winners or losers of each match. Instead, the ranking worked by averaging your score throughout the competition rather than counting wins or losses. And the basic object of the game was to construct towers of storage totes and placing I think it was a 32-gallon cylindrical recycling container on top. And for extra points, you could get extra points by putting standard pool noodles inside of the recycling containers. And additionally, there were some special storage totes that you could place on a shared area with the other alliance, so that both sides could get extra points. Real competition. Yep.
Oh, sorry.
Go
So
ahead.
you put your robot into this area and it did all this stuff. Did it have to be? Was it autonomous, or was there some control?
There's always some kind of autonomous aspect. Usually, like within the first 15 to 20 seconds of the game, it's all completely autonomous. And so, when we're doing that, we're using cameras to detect colors or shapes or anything like that. We've also used retroreflective sensors, because there's almost always a retroreflective tape somewhere on the field that you can use as kind of like a fiducial or something to pick up on. So they usually put it on like a game piece or a goal or something, so we can kind of aim our robots toward that. And then after that 15 to 20 second period, it's all human controlled. We call it the teleoperation period.
So are you controlling like I control a quadcopter where I'm doing direct control, or are you sending it commands and it's following them semi-autonomously?
It'd be direct control.
Okay.
Yeah. So if we have a couple of joysticks for our drivers, they usually control like the left and right side of the drive. So when they want to turn, they
have to work together.
One goes for yeah. So we always have two operators on each robot. So one of them is usually responsible for driving, and the other one is responsible for all the manipulations. Like if we want to grab a game piece, they're the ones operating the claw or the roller or something like that to pick up the game piece. So the driver and the operator have to be in constant communication with each other.
And so you had to stack these totes, and you put your robot in, and the other team put their robot in, and you usually helped each other, or if you were part of the same alliance, or
yeah.
did you just knock their totes down?
Oh no! So this year was kind of a rehash on the 2003 year. They had a very similar object in 2003 where there was a lot of tote stacking, but it turned out it was a lot easier to win matches if you just knocked each other's stacks down.
Destruction being easier.
Yeah, destruction won. Yeah. So this year, that's why they separated everyone this year. So everyone was working to actually stack the totes this year.
So you were alone in the box?
No, we're not alone. We had 3 alliance partners that were also trying to help us build build stacks.
Oh, so you and your friends went into the box together?
Correct.
Okay. Sorry, I just have battle bots on the brain, and I just I think there should be 2 bots, and they should work their best.
No. So in total, there's usually 6 robots on the field at any given time, and 3 robots are on one team and 3 robots on the other team.
And then your robots help you, but there is no knocking over other people's or disabling other people's robots for the 2015.
Correct. For 2015, that's correct.
Before then, there was maybe a little sabotage.
Yeah, a little bit. So we used to not have bumpers on our robot, and bumpers are an interesting thing. They found out that too many robots were getting destroyed by high speed collisions with each other, and they figured that wasn't worth it for First robots to have happen to them. It wasn't looking good for First or any of the teams, because a lot of people were spending too much time repairing the robots. So they had to start putting bumpers on our robot to kind of stop that bending of the metal and stuff like that from happening, at least inadvertently. But there still are some high speed collisions and other types of collisions. And they do get penalized, but they happen. So we have to build our robots to be able to withstand them.
Well, yeah. I mean, that's good practice. And when you have a First team, when you sign up, they give you hardware, right?
Yeah. So First we'll give a kit of parts to all the teams. So if you're a rookie team, you get a little bit more than the non-rookie teams. And it's a lot of it is like control components. Especially if you're a rookie team, or if they're introducing a new control system for that year, we usually get all the control components in the kit of parts. But we also get certain things like springs, some pneumatics, some other kind of switches, electronic switches, just kind of general stuff that you would need to build a robot. Additionally, there's also a kit robot that people can build, and basically what it includes is a workable drive base, and it's up to the teams to figure out what they want to put on this. But they do receive a kit drive base.
And last year, you got a new control system, some sort of Xilinx FPGA.
Well, yeah. So they call it the Robo Rio. The years prior, we had been using a National Instruments C-Rio control system, and while it is an industrial component, it wasn't really designed to be put on mobile robots. So this past year, they gave us a brand new control system called the Robo Rio, and its main component is a Xilinx Zynq. I believe it's like a 7000 series Zynq, and unfortunately, we don't have access to the actual FPGA itself, because they write in a lot of safety code or safety. Yeah, they write in a lot of safety to the FPGA, so that anyone on the field, they can quickly disable a robot if they need to. So that's kind of why they don't give us access to the FPGA. But there's more to the control system than the Robo Rio. We've also gotten a pneumatics control system, voltage regulator modules, and some new motor controllers as well. The First doesn't really want the teams to kind of mess with that stuff too much, because it's all a safety issue. But there are still opportunities to have custom circuitry as well for any kind of sensor suites that we want. So
you can buy your own hardware. It's not like NASCAR where you have to use what's given.
Oh, absolutely. Yeah. Yeah. Almost everything on our robot is that can be custom is custom. So we bend up our own drive base out of sheet metal. We build up our own components. We machine everything. But yeah, there are circuitry that we can create, and I have created. We have got like magnetic sensors that I believe there's AMS Austria Microsystems. They've got a great magnetic encoder system that works great for us, and we can put that on a circuit board if we want, and we can talk through it through like I2C or SPI or anything like that. And So the doors really are wide open for sensors that we want to use.
And yet there are some limitations. I mean, you mentioned it was expensive to participate, but FIRST does put some limits on that.
Yeah, so it's a $400 per component limit. And so that's, if you want to put like a BeagleBone on your robot, you can, but you can't put a huge, massive laptop on your robot because that'll break the $400 per component limit. There's also an overall robot limit of, I believe it's $4,500. They increase it almost every year to kind of keep up with inflation, but it really is a game leveler because there's teams out there that they're able to raise tens to $100,000 to a year to run their team.
Really?
Yeah, absolutely. Yeah.
Oh my goodness.
Yeah. There's a team out in Hawaii. They got a grant to get a water jet sent all the way out to Hawaii. And from what I recall, that was almost a $250,000 machine, but they were able to do it because of all the grants. And that's one of the big misconceptions about FIRST Robotics is that it's too expensive to participate. And I will readily admit that it is expensive. However, there are so many grants out there that teams can get, just to fund their team. Our team runs. We don't have a main sponsor. A lot of teams have a big name sponsor like Delphi or Baxter Healthcare. They do get a lot of money from those companies, but that's one way to run a team. Another way to run a team is to rely on local businesses to give you maybe $500 or $1,000 donation if you put their name on your robot. And there's also other grants out there from like NASA. I believe they give a rather large grant to rookie teams and teams that need help with sustainment. And they'll pay for regionals for you to go to because regionals are expensive. They're about $5,000 for your first regional just to sign up.
You have to pay to compete?
Yes.
Oh, so it's not just the robot.
Yeah. Correct.
And the whole water jet thing, let's go back to that.
Mm-hmm. Yep.
That didn't count against the $4,500 that is the max robot cost because they were building a part using the water jet. Your tools can cost more.
Yeah, your tools can cost more, but only what you put on your robot is what counts against your cost limit. So
that's sort of harsh, but okay.
Yeah. So in our machine shop, we've got a full Bridgeport mill. We've got a CNC mill. We've got a lathe, a drill press, bandsaw, and a bunch of hand tools and stuff like that. Admittedly, we have way more than a lot of other teams that build with just a DeWalt drill and maybe a hacksaw. But the big misconception is that just because you have more money means you can't be competitive. One of the local teams in the Dayton area, they were in one of the urban teams, and they honestly didn't have a huge amount of money, but they were able to build a really successful robot in 2014, and they earned their way to the world championship. Just because that we have the tools doesn't mean that other teams without tools can't build their robot. It's just the tools help us do what we want to do better.
Well, it seems like that playing field is getting more and more level as costs come down on all kinds of tools, and modules that do amazing things are available from SparkFront and Adafruit and things.
Yeah, and things like the tech shop where you don't have to buy your own water jet if you can get to one.
Yeah, no, that is one of the big things that has leveled the playing field in the past several years is that there's been a large amount of vendors that have popped up just selling to FRC teams. Well, they don't only sell to FRC teams, but the FRC teams are their big target. And what that has done is made it so that teams don't have to go out and machine their own gearboxes or anything like that. If they're not happy with the standard ones that they get in the kits, they can go out and buy their own modules so that they don't have to do that. They don't have to do their own machining. But it just helps to be able to customize your own stuff if you want.
Of course. But you as a mentor don't. I kind of want to get to, okay, FIRST is very cool, la la la. STEM education. Yeah, this is great, raw, whatever. But I do want to mention that you volunteer and that isn't necessarily expensive.
Yeah. So personally, yeah, it's not expensive for like mentors to do it. They can donate as much money as they want, of course, but it's not a requirement. And we've never asked for a any kind of monetary amount from our students to actually be on the team. There's some teams that do, but our team does not ask for any kind of money from the students to actually be part of our team.
Well, it's sort of like band. Some bands can afford to not have their students pay for uniforms, and some bands, if you want to be in band in high school, you have to come up with the money for the uniform.
Yeah, and we do ask that they go out and try to find money from the local businesses. This year, we're kind of struggling a little bit because we've lost some of our really outgoing students. But it'll be fine. We'll find. We always find a way to manage. And like I said before, just because a team doesn't have as much money doesn't mean that they can't be competitive. So yeah, finding money from other people is the key.
Okay, so tell me about being a mentor.
Being a mentor, it's a lot of work. It takes a lot of time.
What does it entail? I mean, what is the commitment and what are your goals? Are you the only mentor on a team or are there multiple?
No, we have several mentors on our team. And I guess what it entails, it depends on what kind of mentor you want to be. If you want to be a technical mentor, obviously that's going to require a certain set of skills rather than a business-oriented mentor where you may need to know about money and accounting and all that kind of stuff. For a technical mentor, we've got several kinds of areas that we look at. There's programming mentors, we've got electrical mentors, there's mechanical design mentors, there's manufacturing mentors. And you really should know about your area if you're going to be a technical mentor. So, for example, if you're a programming mentor, you should know one of the 3 officially supported languages, which are C++, Java, LabVIEW. But they should also know a bit about like the controls engineering and sensors. So, yeah, we use PID to control a lot of our components and a lot of our mechanisms to make sure we get speeds correct, positions, and stuff like that. If you're electrical, you should be able to read like the electrical layouts given out by FIRST. And they should also be able to work closely with the programming team if they're not the same people. Usually they are the same people because the programming team's telling what ports are going to be used, like what PWM ports are going to be used for what motor controllers and stuff like that. If you're a mechanical design person, you should know how to use CAD software. Our team uses SolidWorks. Well, we have used SolidWorks in the past, but we're now switching to PTC Creo or used to be Pro Engineer. So they should be familiar with designing for manufacturability with the tools that we have. And the manufacturing guys, they should know how to operate the kinds of machines that we have, like the mills, the CNC, the lathe, and so on.
Okay, so what are the students doing while the mentors are building the robot?
The mentors, that's funny. The students are the ones building the robot. Mentors are the ones guiding them. We've actually we've got a policy on our team that we're not going to let the students fail, but we're going to let the students do the work. So our manufacturing mentor, he tries to not touch any of the machines. And only is a guide to helping out the students. So we actually have students programming the CNC mill and operating the manual mill and the manual lathe. So they're the ones actually building it. And personally, I used to work on mechanical design. I did a lot of CAD stuff. I was a big SolidWorks guy. But this year we're switching to PTC Creo because we got a huge amount of students that were on a first Tech Challenge team, and they all used PTC Creo. So I'm taking a complete step back from that and letting all the students that were on that team do all the design on that. And for programming our robot, I believe last year, our programming mentor didn't even type a line of code. So it really is a lot of student-run stuff, and we're just there to give them good ideas and kind of tell them if they're about to go down a path they shouldn't.
How many students are on a team?
It can vary. I've seen teams as small as about 3 or 4 people, all the way up to teams of, I don't know, 80 people. And
for one robot?
Yes, for one robot. Well, so sometimes one robot. Sometimes teams will build 2 robots. One is an engineering model, and another as like the actual competition model. So more hands do help, but our team's in the happy medium around like 15 students. We find that that's actually a really good number of students to have, because our build shop isn't terribly large. It's about half of a building's worth. But part of that, we have to fit all of our machinery and practice field in. So you just start running out of room if you have too many kids.
Well, then there becomes a management layer. Communication becomes difficult at about, I would say, 8 people.
Yeah, it is. Yeah. And so we've tried to manage that. We've got we do email blasts and stuff like that, and we send out text messages to all the team members. If there's a snow day or something like that, we can tell them, hey, come up to the shop. And that's one of the advantages that we have as a community-based team. We're not associated with the school, so if there is a snow day, we can actually meet. Whereas a lot of schools, they have a policy that all of their extracurricular activities have to be canceled if there's a snow day. So it's really nice to have a snow day. So we can meet all day that day.
Okay, so community teams versus high school teams. We mentioned last week with Abby and Sarah that they homeschool, so they can't participate as easily. But a community team is the sort of team they could join, right?
Yeah, correct. So there are a lot of high schools that have their own teams, and many of them have policies stating that only students from their high school or their school system are allowed to be on that team. There are some schools that are more lenient than that. My high school team, we did allow some other high school students on our team because their high schools didn't have one. However, with a community-based team, they're generally accepting of anyone from any school. So it just gives a lot more opportunities for students like homeschool students. We had several homeschool students on our team last year, several of which have graduated. But it's actually cheaper for the community to have one team rather than have every high school in the area have a team. It's a lot less competitive when you're trying to approach businesses for money as well.
Do you need to have a child participating? You've been a mentor for a while. Either you've got a large family or you don't need to have a child participating.
Yeah, absolutely not. You don't have to have one. In fact, I would go as far to say that most mentors in FRC don't have a kid on their team, and that goes for myself. I'm only 28. I don't have any kids, but I've been mentoring for several years. But however, a lot of mentors become mentors because their kids were on teams. But they find that they like the program so much that they're just going to stay on the team. So what they bring to the table is a lot of experience. So that helps out a lot.
And we started to talk about the commitments of being a mentor, and the subject, the task gets announced in January, and then competitions start in March. Is that right?
I think that's right. There may be one. No, they may be starting in February, late February. They started a new regional this year that was before the rest. We call them week 1 through week 6 regionals. But this coming year we've had to dub a week half regional because it was occurring before all the week 1 regionals were.
That's amazing, because if somebody came to me with something like that as a professional and gave me a few weeks, I think I would say no, forget it.
So you get 6 to 8 weeks to build the robot.
Yeah.
And so that 6 weeks is with a big asterisk. So I kind of mentioned earlier that we build 2 robots. One of them is the engineering model, and the other is the competition model. We've been fortunate enough to be able to afford to build 2 robots, so that after we have past our stop build date, we have to actually put our robot in a large plastic bag, so it's all hands off. However, that's only for the competition robot. The engineering model robot, we can leave out of the bag and do what we want with it. And if we want to make new components, we can do that, and we can attach those components to the robot once we get to competition, with some limits. There's a weight limit all associated with that. But we have pretty much a free reign to do what we want with our engineering model.
And so, have you been working on the engineering model for the whole last year?
No. So they've got some rules in place where saying that anything that you develop, like any of your designs or code you write, you cannot use again unless you share it with the rest of the community. Now, there may be certain things that we can work on, like if we want to work on a new type of gearbox design or a new kind of mechanism, we're allowed to work on that kind of stuff. But if we want to use it on our robot the next year, we have to share it with everyone. We have to share how we design it. We have to share all the source code or any of like the Gerber files for a PCB. All of that has to be shared with the teams to make it an even playing field.
It's an interesting policy. I like that. You can have everything you can develop, but you have to share it next year.
Yeah.
You mentioned the mentors have specialization. I was wondering if the students also are specialized, where you've got kids who are just doing electrical engineering, kids who are just doing mechanical, kids who are just doing programming, or do people kind of rotate around and you try to give everybody a chance to get familiar with other disciplines?
So it's really down to a choice of what the student wants to do. Every year we hand out a form where where they have multiple fields like programming or machining or something like that, and they just tick boxes on their number 1 through 3 choices of what they want to do that season, and then we kind of place them where we best see fit. So some students will they only want to do machining. So, well, I don't really have a choice. I can't really put them in controls because they don't want to learn it, or they don't know it. So we'll end up putting them on machining, but we also may put them on like some kind of assembly job as well. It's really what they want to do. And we're not going to force people to do something they don't want to do, because then they're just not going to come at all.
Well, yeah, this is all voluntary. It's they're not getting school credit, at least not on a community team. They're not getting school credit.
Well, sometimes they do. We've had some agreements with one of the local high schools where they have been getting some. It's kind of like an engineering credit for being on the team, but they have to. It comes with some other requirements, like documenting all the stuff that they do. I'm not really sure if they still offer that. I know as of a couple years ago they were.
And so it's a huge commitment for the students. Like, how much time do they spend starting in January to whenever they get knocked out of competition?
So again, that's one of those things that differs for every team. But speaking for my team, we meet Monday through Thursday for about 3 hours a day, and then on Saturday from like a 9 to 5 kind of thing, and that goes on for the 6 weeks of the build season. And we'll end up cutting out a couple of days after our stop build day, but so it really does become quite a time commitment. But it turns out it hasn't really been an issue for a lot of the team members. We've actually found that a lot of team members will continue to they'll continue to design while they're at home, even after our practice is done. I remember in 2012 we had some really committed students that they kind of almost got in trouble in like their physics classes because they were more concerned about the robot than they were the classes. But so they were trying to design components while they're getting a physics lecture. But it's something that they want to do, and I can't stop them from continuing to want to work on the robot.
Is that the same level of commitment and presence that you expect from your mentors, or do they get a bit of a break?
Mentors do get a bit of a break. Personally, I'm more of the super commitment one. So I haven't. There hasn't been a day that's gone by in the past probably 3 or 4 years that I haven't been thinking about something about trying to help our team out, whether it's trying to come up with a new design or how can our team operate in a better way. There's always something that gets brought to my mind every day for the past several years that has made me pretty committed to our team. But not every mentor is like that. There's other mentors that this is kind of what they do as a hobby, and they don't have the kind of level of commitment that everyone does, and that's okay too. We need people with all levels of commitment. And we're not going to turn anyone away just because they're not too committed. However, the issue arises when we have a mentor who wants to be there for like 1 day a week, and that really does kind of detract from the team because we end up needing to explain what's happened through the past week and play catch up with them. And so instead of me working on the robot, I would have to explain to the mentor that hasn't been there for so long. What we've been doing.
Okay, so if I wanted to be a mentor, I should expect to spend probably 3 or 4 days a week hanging out with the students and working with them and being available by email and stuff.
Yeah, I would say that's pretty on par with what most mentors do. I'm not like most mentors. I've driven headfirst, but most mentors I would say are probably a 3 to 4 day.
We're trying to encourage people here. We don't want them to believe that it's going to take over their life. So this is all very sneaky. Less sneaky now, but okay.
I'll put it this way. I'm insane. Most mentors are not.
But if you don't want to commit to be a mentor, because it is a commitment, and it's many weeks long, and it gets longer and longer each time, I suspect. Although I've never done it, so it does sound interesting. But I have been a judge just once, and it was super cool. Can you tell people about signing up to be a judge and what skills they need?
Yeah, so on the first website, there's a whole section for like new volunteers, so that'll guide you through the process of becoming one. And first has like a volunteer management system where you can sign up for positions at any given event, including a judge. And so there's a text box where you can kind of explain who you are and why you feel that you should be qualified. And so each event needs like a panel of judges that are either technical or non-technical, since awards are given for technical and non-technical achievements. So generally for FRC, the non-technical judges, they're like the business type judges. They tend to be people like CEOs, military officers, and like founders of nonprofits. However, the technical judges are generally like a senior engineer type position. However, for like first tech challenge and first Lego League events, the judge credentials aren't generally as strict. So I was recently a technical judge for an FTC competition, and I'm just a regular engineer with like 4 years of experience. And I've been an FRC mentor for several years. So you don't need to, if you don't feel like you're qualified to judge at FRC, perhaps take a look at FTC or FLL. So what kind of judge were you for? Were you an FRC judge?
It was FRC.
Okay.
And I don't really recall much more than that. It was many years ago.
Oh, okay. So I assume you're like a controls type person or a controls judge or something like that.
It was pretty general, like making sure that they stayed in their. Chris, you were there.
I can't remember.
I know. It was so embarrassing.
I think we had a very, very specific minor role because we kind of parachuted in for a day. So
yeah.
It was very early though. I think it was in the 90s. So.
Yeah, it was really interesting. That was the first time I ever judged this past weekend, and it was amazing to see the judging process, because when you're on a team and you've never been a judge before, you don't know anything about what are what are the judges thinking about, or how do they even operate. So that was a really good learning opportunity for me to see what goes into the judging process, how are the rubrics done, and so it does kind of give a leg up on the FRC awards as well. Even though it wasn't an FRC judge position, I guess they're run pretty much the same way.
it is always useful to be on the other side of the table when you're trying to win a competition, which just makes me wonder if I should be a Hackaday judge next year, if I should just try to participate.
Oh, God, no.
Which one's more work?
Let's just say
different kinds of work.
There was different kinds of work. Yes, that's the safer thing to say. Okay, so there are all sorts of judges. It's usually about a day's commitment and not many days for many weeks.
Correct. Yeah, correct. Yeah, it's usually just either a Friday or a Saturday. So maybe sometimes both, depending on what kind of judge you are. You're treated like I don't want to say godlike, but you are an important person. When people see you wearing that blue shirt, they immediately start being very nice to you. It's kind of funny how that happens.
And you don't have to be as technical to be a judge, because there are all sorts of roles. And not just judging roles. There are the volunteer roles. There's the ones that make sure that do the weighing in and make sure you don't have sharp edges and all of that, which is sort of fun to see how people solve the problems.
Yeah. That's actually the robot inspector position. I actually have done that for FRC, and I've done that for a couple of years now. And that actually is a really that is a really fun position to be in. But there are some heartbreaks with that, because sometimes you got to tell a team that, oh well, your robot is too big. Where's the hacksaw? We're gonna have to cut off cut this down by about 6 inches. So of course we're not the ones doing that, but we have to be the bearer of bad news to them. And I've seen that happen.
That would be bad news.
Oh yeah, it's terrible. Teams can come in 20 pounds overweight. I think our team, the first year that we competed, we were about 20 to 30 pounds overweight, and it was a madhouse. Apparently, I wasn't on the team yet, but I just hear so many stories about it, and it doesn't sound like a place where I want to be.
Well, the different roles, I'll put a link in the show notes, but the different roles, they say, if you want to do this, you should be able to stand for long periods, or be a communicator and be able to sit for long periods, or be upbeat and detail-oriented. So there are roles for everybody, and not all of them require lots of engineering. So you engineers can volunteer and bring your significant others, boyfriends, whatever.
What?
Sorry, that's a Twitter argument that just leaked in. Somebody out there is laughing their head off. Just the one, though.
I've tried to get my wife involved, and she doesn't seem to want to be a volunteer. She says that she'll do it, but I know I'll tell her to go volunteer, and she'll have second thoughts about it.
So to be a volunteer, you go to the firstinspires.org page, and you sign up, and you tell them what qualifications you have, and they try to match you with what location you're in and all of that, because it is 19 countries, so it isn't just U.S. When you want to join a team, you want to be a mentor, or you want to try out being a mentor if you're not quite sure, how do you find a team?
First on their website, firstinspires.org has a find a team. They have a find a team website where you put in your location, and it'll tell you all the teams that are in the within like a 20-mile radius of you. So that can kind of help out. You can also email FRC teams at firstinspires.org and tell them your situation, and tell them that you're looking for a team. They can help out. However, what I found the easiest was going to a website that is really like the official, unofficial forum of First Robotics members, and it's like chiefdelphi.com. And I just put out a message on there saying, hey, I'm new to the area and I'm looking for a team. And it was amazing at how many responses I got. And so within a couple of days, I was on a team in the area.
All right, Chief Delphi. There were a lot of forum posts about lots of detailed, neat things on Chief Delphi.
Mm-hmm.
So cool. It's another place to look if you're just trying to figure out if this is something you want to join.
Yeah, and that's actually one of the places where people share designs, and they always put out in the first always puts out in the rule book that you should put your designs in a publicly accessible forum. They won't outright say Chief Delphi, but we all know what they mean. But so if you want to reuse a component, if you post it on there, generally it'll be that's an accepted publicly available forum where it's acceptable to put your designs.
So what has been the best part about being a mentor?
I would say seeing the kids develop from perhaps being in their own world or in a shell, and you see them come out of their shell. And that there's one kid that I have in mind. He came onto the team as a freshman, and he was really quiet. Didn't really talk to too many people. He was but he did have an interest in programming, and so we kind of put him to work as a developer for our scouting system, and he really got into that. And once he got to competition, he became a lot more vocal about his accomplishments, and he became really proud of what he did, and that's really allowed him, to come out of his shell. And now he is talking to judges at every competition that we have, and that's been one of the greatest things to see. It's see the kids grow up from when they're freshmen to when they're seniors. So he's a senior this year, and he's super proud of all of his accomplishments, and that's one of the greatest things as a mentor to see.
And I think that actually answers the question of why would you join a FIRST team as a high school student?
Yeah, it's not only monetary. We have as a team, I believe we're responsible for about 48,000. So alumni of our team have gotten $48,000 in scholarships with just first related scholarships, and I believe that's with only 25 alumni overall. With the scholarships, if you include academic as well, and they put us on their application, put our organization on the application, they've generated about $1.2 million in scholarship money. So part of that is a reason to join a team, and that's why a lot of parents are very willing to let their kids be on a team that has this kind of time commitment. But it's not only the monetary stuff. It's learning something. It's meeting new people, and it's being able to interface with engineers and also the manufacturers, one-on-one. It's a place where people can learn skills that they wouldn't ever learn anywhere else as a high school student.
Yeah, definitely. I mean, I was thinking when you mentioned SolidWorks, what an incredible, advanced leg up that would be coming into college, as a mechanical engineer or whatever.
Just being able to know and see what the different kinds of engineering are.
Mm-hmm. Yeah. And then, gravitate toward what appeals to you a little earlier. I know I had trouble in college once I'd done a lot of technical things in high school, but getting into college was like, I have no idea what I want to do. There's too many things.
Well, and I've said before that if you would like to have me pick out your resume from a new college pile, be on the robotics team.
Yeah.
That is just the best all around, see everything, and being able to do that in high school is even better.
Yeah, and I guess there's now a standard application for colleges, and it turns out FIRST Robotics is now on that standard application. And I'm not sure if that's for colleges or for scholarships, but I've heard the term standard application thrown around with FIRST. But FIRST Robotics is now on that application. So it just lets businesses know that that's what they've been involved with.
How much of the competition is just showing up with a robot that meets all the rules and functions at all?
It hasn't been so much within the past few years. It still does happen within the first couple of weeks where people are still trying to get their robots tweaked and working. But as I mentioned before, with all the new vendors coming out with new components all the time, they're also becoming a lot more reliable. So teams are no longer struggling to just start driving like they were from about 1992 to about 2004. They're now able to get driving fairly reliably at competition, and now it just becomes a matter of just tweaking your manipulators to gain control of the game piece, and that's kind of the evolution of FRC that we've seen. Teams are just as a whole getting better. Even the rookie teams are getting really phenomenal. I've been super impressed with especially the rookie teams this past year and what they're able to do. So the barrier to a successful robot has been lowered substantially in the past few years.
What do the teams that win awards do differently?
So there's several things that happen. Teams that win awards generally have their own goals aligned with FIRST goals. And so a big part of that is making FIRST ideals of gracious professionalism and cooperation, to the heart of their team. Our team is a 501c3 nonprofit, so we have a documented mission statement that we're going to increase the number of STEM opportunities in the education system and inspire students to explore STEM careers. So everything we do as an organization is working toward that goal. So while trying to achieve our own organization's goals, we've naturally become aligned with FIRST goals, which are nearly the same. So that has really helped us out with getting on the awards panels. So our team does a lot of community outreach activities. So that helps out with a lot of the community-based awards as well.
Well, like what do they do?
So, for example, our team has we've taught a week-long science camp at one of the local science centers. We've taught first through eighth graders how to build Lego robots, and we even demonstrate basic science principles. And so we also host a lot of FIRST competitions as well. We go around the community with our robot. We've gone to air shows with them. We've gone to the Dayton Hamvention with our robot, just to kind of show the community, this is what the kids are doing. And so that's doing those kind of demonstration kind of really spreads the word of FIRST, and a lot of that is on the awards criteria.
I had no idea. That is very cool. So it's not just build a robot, chuck it in a box, win some points, and go home.
Right. Yeah, it's a lot of interfacing with our community.
Very cool. I'm about out of questions. Christopher, do you have some?
Yeah. So what's the most surprising thing that's happened at one of the competitions to you?
To me.
Oh, well, I mean, what is surprising to you?
I would have to say the local team that with very few tools, finding a strategy that they could build the robot to accomplish. It was a very simple strategy, but with very few tools, they were able to get a world a world championship type robot. That was super surprising to me.
You don't need the $250,000 water jet to win.
Not at all. But hey, we've got access to one. So,
did they come up with particularly clever solutions or workarounds, or were they just more resourceful? How did they manage to do that?
So one of the biggest problems we have as an FRC team is wanting to do too much. We try to accomplish every little thing that the game can do to win as many points as possible. But what this team did was say, well, we know that we can't do all these complicated things. We're going to specialize in this one very specific task, and we're going to do it the best that we can. And it turns out they were the best at the competition at doing their one task, and it paid off for them really well.
Focus. Sometimes focus is where it's at.
Absolutely.
All right. Well, I think we're going to wrap this up. It is still technically holiday weekends and time for us to go out and play.
I hope so.
Do you have any thoughts you'd like to leave us with?
Yeah, I just like to get the word out that out to the entire electronics community that there is an entire organization that wants you. They need your skills. And there's a lot of kids' futures that could really be affected by you.
That is good to know and important. My guest has been Michael Hill, an aerospace engineer and the mentor of Innovators Robotics in Ohio. Thank you for listening. Thank you to Christopher for producing and co-hosting. You know that if it was up to me, this would all sound like it was recorded in a paper bag. He makes it sound much less like that. Much less. If you'd like to thank him or talk to us or say hello to Michael or even tell us about your first experiences, because I'm always curious, hit the contact link on Embedded FM or email us show@embedded.fm. Also, don't forget that we like having podcast reviews on iTunes. So if you failed to send us a gift this year, that one will do. Late is fine. We will be here next week. In the meantime, a final thought to leave you with. No, not the 3 laws, although I thought about that. This one comes from Ancillary Justice, Anne Leckie. Thoughts are ephemeral. They evaporate in the moment they occur, unless they're given action in material form. Wishes and intentions the same. Meaningless unless they impale you to one choice or the other, some deed or course of action, however insignificant. Thoughts that lead to action can be dangerous. Thoughts that do not mean less than nothing. Embedded FM is an independently produced radio show that focuses on the many aspects of engineering and robotics. It is a production of Logical Elegance, an embedded software consulting company in California. If there were advertisements in the show, we did not put them there and do not receive any revenue from them. At this time, our sole sponsor remains Logical Elegance.